Alright, so we are now on Unit 8, Lesson 7. And honestly, this section is probably one of the most difficult sections for students to understand. And it is understandable why, because it is relatively confusing. It's called Le Chatelier's principle, but that's not a term that you need to know. Basically, in a nutshell, Le Chatelier's principle deals with the following. If you have a system, and when we say system, we mean a reaction that's at equilibrium, the reverse and forward reactions are going at the same speed, and you change something in that reaction. In other words, you place a stress on it. And the stresses that can be placed on it would be a change in either the temperature, you either heat or cool the reaction, you change the concentration, you either add or remove substances, or that you change the pressure. You either increase or decrease the pressure. That's called placing a stress on the system. And the reaction will react or will shift in order to relieve that stress that you've added. And what you have to be able to do is, given a chemical reaction, when they tell you, for example, if we increase the temperature, or we increase the pressure or decrease the pressure, etc., you have to be able to determine what direction the equilibrium is going to shift, either to the right or to the left. Once you've determined that, you will then be able to determine that whatever side it shifts to, those materials, those substances always go up in concentration. And the side that it comes from goes down in concentration. And if you look at the bottom here, this is a very important term that might come in handy at some point. You may not have to use this, but you should keep this in mind. Add opposite, remove same. And you'll see what we're talking about on the next slide. So this is kind of going through what we mean when we say it shifts to the right. So again, you have a chemical reaction. You have the reactants on the left side, the products on the right side. When we say that the reaction shifts to the right, or the equilibrium shifts to the right, that means that the forward reaction is increasing in speed, so it's no longer at equilibrium. And you see how these arrows are not the same anymore? You notice the arrow going to the right is bigger, and it's longer. That's because the reaction is not at equilibrium anymore, because these arrows are not equal anymore. Now, eventually, it will come back to equilibrium once the stress has been reduced. Shifting to the left means that the reverse reaction is going to speed up. So you notice in this one, the reaction going to the left, the reverse reaction, the arrow is bigger. That means that this is no longer at equilibrium because you just placed a stress on it. And we're going to go through exactly what the stresses are in just a minute. So let's go through that. We're going to look at, the first one we're going to look at is concentration, and how changing the concentration makes it shift. And this is where that phrase, add opposite, remove same, comes into play. Here is our chemical reaction. Notice that it is at equilibrium. It's a reversible reaction because you have that double arrow. The arrows are the same, so it's at equilibrium. So everything's nice, copacetic. What you're going to be able to do, or what you have to be able to do, is when we talk about changing the concentration, is you're either going to be adding or removing reactants and products, and then tell what direction it's going to shift in. So remember the phrase from before, add opposite, remove same. That means that if you add more of a substance on one side, the equilibrium is going to shift to the opposite side. If you remove something from a side, it's going to shift to the side that you removed it from. So for example, if I add NH3 or O2, add opposite. So if I add to this side, the equilibrium is going to shift to the right, which means that these will go up in concentration. Same thing if I add it to this side. If I add more water to this reaction, or more NO, it's going to shift to the opposite side. Now, removing is different, right? It's the exact opposite. If I remove from one side, so for example, if I remove NH3 from this reaction, or oxygen, the reaction is going to want to replace what I just took out, so it's going to shift in the same direction. So remember, remove same. Whatever side you remove from, it shifts to the same side, and whatever side it shifts to goes up in concentration. Whatever side it shifts away from goes down in concentration. So let's take a look at these. If we add H2O, so remember, if we add opposite. So if I add to this side, it's going to shift to the left. Let me get my pen here. It is going to shift to the left, and the NH3 would increase in concentration. If I add O2, so now I'm adding to this side, remember, add opposite. If I add to this side, it's going to shift to the opposite side, so it's going to shift to the right. And they're saying if it shifts in this direction, what's going to happen to that amount? Remember, whatever side it shifts to increases in concentration. If I add H2O, which is basically the same thing as this, we already said, would shift to the left, what would happen to this amount? Well, if it shifts to the left, this is going to go up in concentration, which means the NO is going to decrease in concentration. You know, if one side is increasing, the other side can't if one side is increasing, the other side can't increase simultaneously, right? So if one side's increasing, the other side has to be decreasing, and vice versa. If we add NO now, add opposite. If I add NO, what would which concentrations would decrease? Well, if I add NO, the equilibrium is going to shift to the left, which means that the NH3 and the O2 will, oh, I'm sorry, it says decrease. What will decrease is the H2O, because whatever side it shifts to goes up in concentration, but this side will go down in concentration, so the H2O will decrease. So if I add NO, equilibrium shifts in this direction, producing more of that, but in the meantime, this is getting used up, so that concentration will decrease. Let's take a look at the bottom one. Another equation here. Actually, it's the same equation, just giving you some different questions. So now they're saying if we remove oxygen, well, remember, remove same, which means whatever side you remove some from, it shifts to the same side. So if we remove oxygen, it's going to shift to the left, which means the NH3 then will increase in concentration. This will go up, and those will go down. If we remove water, so I'm removing water, remove same, it's going to shift to the right, and the NO will increase. Whatever side it shifts to goes up in concentration, right? If we remove ammonia, that's ammonia. If we remove ammonia, it shifts to the same side, which means it'll shift to the left, which means the other side, the NO side and the H2O side, will decrease in concentration. Whatever side it shifts from goes down. If we remove NO, remove same, it's going to shift to the right. So if it shifts in this direction by removing NO, that means the H2O will go up in concentration. Okay, so that's first part.